So, hello everyone. I think we are ready to go, and thanks for joining the stream today. My name is Mikkel, and I am part of the. Sorry, I just had some audio issues. Okay, should be good to go. My name is Mikkel. I am part of the Fermyon team, doing developer relationships and product management at Fermyon. And today I will be solo streaming. A lot of my colleagues are at conferences presenting things and really busy doing other stuff. So I hope you will watch along and make sure to write in the chat. I'll keep an eye on my chat, and it might take a little bit of the focus away as we go along, but let's see if we can do this. Hello, Wamshi. Thanks for joining. But today, I will be talking a little bit about something that I also wrote in our release blog post for Spin 2.6, which is about how we've started sort of experimenting or getting to the next level of support for WebAssembly components with Spin. So basically, we will be looking a little bit at what is this whole WebAssembly component thing. What does it mean with WASI 0.2.0 having WebAssembly component support? How does that all relate to Spin? And how can you use these things together? And also, how are we using the core technology here within Spin? And finally, how using OCI registries as a way of distributing components can be done. And again, how this maps to Spin. So let's just go ahead and have a look at, well, let's talk a little bit about WASI 0.2.0 to begin with. And I might want to start sharing my screen here. So let's say I want to do an entire screen, this one. And I know Ronan, our designer, will be proud of me that I'm trying out the new slide feature in Figma. So shout out to Ronan for making us use Figma, or introducing us to, inspiring us to use Figma. It's a nice tool, and creating slides in Figma is actually really nice as well. But WASI 0.2.0, so this specification of the WebAssembly system interface, there were two very important pieces of WASI 0.2.0 that we have adopted in Spin. The first one of those is support for component model. So based on the WebAssembly component model, we're able to now use, have real cross-language and virtualization support with WASI, which means that the way that we can build experiences around how this concept of guests and hosts work together is now a core piece of the standardization in WASI 0.2.0. So when I talk about guest and host, and if you think about Spin applications, really, when you build a Spin component, you're creating a guest component, and it's a guest component to Spin being the host running your guests. And really, within the component model, you can sort of continue chaining these guest and host relationships. So even if your Spin component is, importing functionality from other components, now that you can say comes a host in relationship to another guest, but having this way of composing applications together is part of the core specification, and is how it's being used in Spin. We did this prior with Spin as well, but not using the component model specification. And you can go back and find really old blog posts from Radu Matei, our CTO, who talked about how linear memory in WebAssembly is how you can sort of share things across individual modules. And basically that is part of what we previously did in Spin, but now we have this standardized way of doing it with WASI 0.2.0, which is based on the component model. The second thing is that there are two WebAssembly interface type language worlds, so WIT worlds, which are part of WASI 0.2.0. One of them being WASI CLI, which is basically the command line interface world. So if you wanted to write a component that have access to environment variables, standard in, standard out, and those type of things, you would be targeting that world. And then WASI HTTP, which is an HTTP proxy world. So basically a world designed for the scenario of handling HTTP requests. And again, relating to Spin, WASI HTTP is a core thing that we do with Spin, and now it's actually standardized how that interface interface looks. So those are some of the key things that happen in WASI 0.2.0. And let's dive in and start doing some coding and see what this even is. Like how do we based on a WIT world, like a WASI HTTP WIT world, which is a definition of this interface that you would have to implement if you want to be an HTTP component in this case. I have a few examples of these that we can start walking through. So let's go ahead over here. So first of all, I'm actually using a sample here. Let me just pull a browser over here as well, and then we can go ahead and take a look from where we got this. I am using this example from Sunfish Code. So Dan Goman, who's part of the Bytecode Alliance, or I don't know if Dan has an official role in Bytecode Alliance, but Dan does a lot of contributions of the Bytecode Alliance tools that we that is part of this and that we also use. So Dan sort of has this hello WASI HTTP example that is sort of the core of how you would implement a WASI HTTP incoming handler. And there's a few things in this that we can sort of try and see to how do we get from having nothing but the WebAssembly, the WIT definition of this interface, and then how do we implement that? So let's go over here, and I'm probably just gonna change my background to light because it might be easier to see for people. So I see Keepa has a question. Keepa, I don't know if I get the name pronouncing exact correctly, but there's a question about whether I can tell more about WIT with some examples. Yes. We can look at some WIT right now as we go through this WASI HTTP, and we can talk a little bit how that works. Because there are multiple components that, well, didn't mean to say components, there are multiple things here that sort of needs to be put together and line up so that we can come from that WIT definition and actually have an implementation of it. This example, by the way, is written in Rust, for those, if you haven't noticed by now. But what you can see in here is that there is this world definition. And basically the world is called target world. You can name these worlds the way you want in terms of in terms of the context, the scenario that you're building your applications in. And there's a package name as well. And basically what this says is that this world includes the WASI HTTP proxy. Now, what is that WASI HTTP proxy? That is basically what you, an implementation of this is you building a spin HTTP component, a spin HTTP triggered component. And so WIT has this syntax of defining worlds, and by the keyword including, we're actually pointing to some dependencies, but we can also define our own interfaces in here. So if we look at those dependencies, we can see over here we actually have the specific proxy world. And all of this is, you don't have to write this like this example. We have the WIT definitions locally, but we could reference them remotely by various tools. But a lot of these tools are still work in progress, especially around distribution of WIT definitions and components and so on. But it is possible to do that today. I think the main thing to think about here is that we can see there's another world here which just have a bunch of imports, which means there's another layer of interfaces underneath, you can say, that we are using. And then what we are doing for the particular proxy world is we include all those imports, and then we export that incoming handler, meaning that if we were to implement a version of this proxy, we will build something that exports an incoming handler. And an incoming handler is basically the thing that handles an HTTP request. And again, if you think about spin, this is what you do if you build a spin component. Okay, so once you have these WIT files, you would then go ahead and use a tool to create a set of bindings. And basically these bindings, and it varies a little bit depending on what language you're in. I have colleagues that can talk more about in depth about this, and if you have any follow-up questions that I'm not able to answer here, please go ahead and join our Discord server and feel free to start asking questions there. But basically, there are tools that we would use to generate bindings. So in the language we want to write our guest in, so where we want to implement this handler, we could use a tool to create these bindings. And I think the main thing I just want to show by showing the generated bindings in Rust is that you can sort of see that all the interfaces that were defined in those with now, are turned into Rust codes, right? So there is the WASI CLI, standard out, and standard in, and we should be able to somewhere down here also find the proxy. Let's see if we can, well, we didn't find the proxy here. Let's see if there should be an incoming handler somewhere. Yeah, there you go. Okay, so here we actually have the incoming handler that is being exported as well. So anyway, this is all generated code, and these bindings, you're not supposed to work with these, but we have to have, like, by having them locally, there are sort of two scenarios, again, depending on programming language. In some languages, the bindings are being used as part of the compilation, part of the compile tool chain that we'll use later. In other languages, and I think particularly in Python and JavaScript right now, the bindings is merely just a way of helping you, helping the editor with resolving interfaces and modules that are being generated. Okay, there's another piece to this, and this is very specific to how Rust works. And again, depending on languages, the tool chain varies a little bit. You can see how Rust through Cargo has you call it native support for understanding components. You can see all our dependencies are basically defined in here. So pointing back to all those with definition files that we saw before. So if you, and we're actually going to get back to this, because we're going to try and build one of these ourselves a little bit later. No, we're actually not going to get back to this, but I just wanted to show that Rust out of the box have some support through Cargo for handling with dependencies like this. And again, there are other tools out there for dealing with WIT. Particularly, there's a tool called WAC, W-A-C, which is also, I haven't played a lot around with this. I know a lot of my colleagues are both contributing to the tool and using that tool as well, but that's another way of dealing with WIT dependencies. So, okay, now that we sort of have those things in place, we have the WIT definitions that define what we need to implement and what interfaces are made available to us by that host. We have the bindings generated, then we can go ahead and implement our particular incoming handler. So this is just Rust code that is written, that is using, you can see importing those bindings, taking in some of the types that are needed, and then implementing the incoming handler, which is an export from WASI HTTP incoming handler. And basically, we are just responding, hello, WASI HTTP proxy world, and replying with that. Okay, so what we can do now is we can go ahead and we can build this as a component. And again, this is sort of the fourth and last thing that is needed for this whole thing to line up, which is you need that particular build tool to actually go ahead and build a component. So in this case, in Cargo, it's Cargo component. And with Cargo component, we give it a build command, and we say we want to target Wasm32 WASI, which again is a Rust-specific compilation target for creating these WASI components. We get a few warnings in here that there are unused things in our bindings, which is okay. We might actually be able to clean up the world a little bit, but it really doesn't matter in this case. But we do have a hello WASI HTTP WebAssembly module which was generated, and you can see that right here. So we now have a Wasm module, and this is something I love to do whenever I end up creating these Wasm modules. Is like, what did I put into this WebAssembly module? Do I have the imports and exporters that I expect? And so Ryan Levick from our team built a nice tool called WebAssembly, which I always end up using in these cases. So we could actually go and hand over the WebAssembly to WebAssembly, and you can say that WebAssembly understands and can sort of introspect, or whatever you want to call it, the WebAssembly module, and you can see that we actually have an export in here, which is our incoming handler, and we have a bunch of imports, which sort of follows the whole trail of the dependencies that we had inside of this. So this seems to be a good WebAssembly component. And the last thing we then need, I guess I said 4 before, and we might be at 4 or even 5 at this point, but the last thing we then need is the runtime that understands running a WASI HTTP component. So this is basically our host. You can use Wasm as a runtime, and I think what we want to do here is, I think we should be able to just do, I actually didn't plan this at that time, but let's see if I can just do, I need to go to Wasm debug. I think, oh, there you go, okay. So now we actually use Wasm as the runtime to serve, and Wasm serve, so Wasm serve command is actually an implementation in Wasm that implements sort of the other side of the proxy. So the part that exports all those interfaces that are needed. So which is also the part, like the host part, that is looking for that incoming handler. So basically what we're saying is that we want to serve the incoming handler through that WebAssembly component. And we should be able to do a curl against this, and we can see that our WebAssembly component is responding, which is nice. But what we did with the latest release of Spin is we actually have that same support in Spin. So Spin usually requires you a spin.toml manifest, which on top of what Wasm serve, for instance, can do, enables you to sort of bundle multiple components or triggers, HTTP handlers together in one application, which is one of the big strengths of Spin. Like you can sort of, consider this. You could build, you build microservices types of applications, but you can actually develop and debug and run them locally as if they were a monolith. Like you don't have to think about a bunch of dependencies. And a lot of the things that Spin add with, key value store and SQL and, security around outbound access and all those things. Like you need a Spin manifest to define how that component should run together with other components and those configurations. But we actually have this concept in Spin now where we can do, I think we call them manifestless applications. I'm not sure exactly what we're going to call them, but spin up command, I can use spin up, I can do -f or -- from, and then point to my WebAssembly component that I have. And now we get the exact same experience, although, whoops, it is on a different port. But again, we're able to take this WASI HTTP component and we can just run it directly in Spin. So this means that, any programming language that we can use to create these WASI HTTP components in, we can now take those and run them directly in Spin, and we can run them directly from a WebAssembly, or we can actually reference them from a registry, and we'll get back to that a little bit later. I want to show another example here where we are using Python. And in this case, let me just get the background to light. In this case, there's another set of tool chain that is available. So the main thing is a tool called Componentize.py that enables us to both generate bindings and enables us to compile into WebAssembly. I actually haven't generated the bindings here. But this application then, again, you can see the same, the with interfaces that we looked at before. Again, I imported here now in Python. So we import a set of types from the proxy, and we end up exporting our incoming handler down here. And we can just try and run this. Well, let me actually, oops. Let me go back up here. That's what I wanted to do. And I actually should have it. Okay, so we can run Components.py as the command. We point back to the with files that we have there here in the directory structure. We're saying that's a particular world that we're targeting, and we want to componentize app.python, and we want to get http.wasm as the output. So this is similar to doing cargo component builds, but again, it's a different programming language, so it's a different tools in that we use. And again, we need those same components: the with files, the world we're targeting, the actual code, and then we have the output. And now we can serve that WebAssembly module using spin up. And we already have, so I think we can do something like this. I could probably also just shut down the other one. Well, that's not, okay. It's just listen in Spin, there you go. So I'm just gonna tell this Spin instance to listen on a different port because I still have my Rust thing running. So we can go and curl this one, and this one has an echo endpoint. And if we say hello, it says hello. And if we say hi live stream, there you go, hi live stream. I even cased that. But anyways, this is what happens when you do these live things. Okay, so just trying to bring these things together when we talk about what we need to build this type of a WASI HTTP component. And so there's nothing in here that I used when I developed that is spin specific. These are basically, you could say, the set of tools that you can use, and that we also implement as part of the developer experience with spin. And we'll get back to that in just a bit. But just enumerating the things that are needed. Like, first of all, we need the with definition that we're going to develop against, right? So in this case, WASI HTTP is that standardized way of writing incoming HTTP handlers. Then we need our binding generators, so the ones that helps translate with into the programming language we use. With BindGen is a bytecode alliance project. I should actually just find it over here. That would be easier. And with BindGen is a project that creates these guest language binding generators. Well, create guest language bindings. And there are various program languages that are supported at this point, and I think we can get an overview by looking at potentially the crates over here. Yeah, so C, C#, Go, Guest Rust, Markdown, probably not Markdown. I don't know what this is. Anyways, let's not try and answer that. But anyways, there's some Java stuff and there's some Rust stuff in here. So there's a set of programming languages that are supported in terms of generating these bindings. I'm actually surprised I'm not finding JavaScript in here, but maybe we can figure that out in just a second as we move on to the build tools. So again, we have the with definition. We're using the binding generators to create a version of those interfaces in the programming language we want to use. So now our tools can resolve, and we can get all the help we need in our editors. And then we need to compile this. Again, depending on your programming language, you can either in Rust, there's a Kafka component, and then for Python, componentize Py, JavaScript, componentize JS, and .NET, componentize .NET. All of these are also bytecode alliance projects. And if we really just want to get ourselves off the thing, you can take a look at componentize JS. And I assume componentize JS actually has a way to generate bindings then, because I'm not sure how JavaScript is doing this today, to be honest. If anyone in the chat knows, just let us know, and that will be super helpful. But I hope you sort of get the overview of what's going on here. And then finally, as we have our WebAssembly components, we need a runtime or a host that understands, that is, that implements the other side of the world that we started out with. And for WASI HTTP, you can use Wasm Serve, as I showed you. You can obviously use Spin, a CLI. You can use SpinCube if you get into Kubernetes. And then the next unit is a web server that also understands WASI HTTP and are able to run these WASI HTTP components. So I hope that this sort of gives you an idea that there's hopefully an ecosystem emerging around this, where components being written against these standards, that is your guest implementation of an HTTP handler, you can go and deploy in all these various environments where runtimes or hosts are being built that provide both the base capability of handing you the HTTP request, but also other things around them, whether it being developer tooling or integration with Kubernetes, like we have in SpinCube, and how we can use Kubernetes sort of native ways of getting configuration and other things to Kubernetes secrets back to you. So all these hosts specific ways of implementing what you need to actually run these things. Okay, I'm gonna just turn attention to the chat a little bit and try to answer some of the questions in here. And so let's see. Can you tell more about WIT? I think I told WIT, and we saw an example of WIT, so that should be okay. If there was something specific, keep it, please just go to the chat. Would love to see Python server components with HTTP, like inference endpoint. Also, how far can we package a full-fledged Python app? So for the first one about the Python component, I mean, I did show the HTTP incoming handler implementation that you can use, that you can do in Python. With inference endpoint, I'm not sure exactly what you're meaning there, but Spin actually provides embedding and inferencing APIs so that you can hook in some models on the other side, like in Fermyon Cloud, we provide some of those. If you run Spin locally, you can really configure it yourself and use those as a way to do inferencing. This, however, is specific to the Spin SDK. There is a WIT specification called WASI NN, which is out. Which I don't know much about WASI NN. I know it exists, but it is meant to, as far as I understand, also have a definition for what the world of AI, what some of these interfaces can look like, and various hosts that support these would be able to implement a way of providing some of that. So that might be a place to go look. How far can we package a full-fledged Python app? There's a bunch of stuff in Python that is not compilable to WebAssembly today. I would say far, but used to be this far. Maybe it's this far now. There's a bunch of stuff that needs to happen in the ecosystem in order to be able to do that. Also, how far can we package a full-fledged Python app into a component and use it with a Spin app orchestrator? So this is an interesting one because, I mean, depending on how much work you want to do, if you specify that those APIs that all the Python languages you use rely on, then you could create a WIT definition. I guess theoretically, I have no idea if this is practically, but theoretically, you could create a WIT definition that is basically just that API that you expect, and then you can, the runtime that you end up building that provide those interfaces can be built in and is typically built native. Well, it is native code, like Spin is compiled to native code. So you don't have sort of the WebAssembly shortcomings or restrictions in terms of what you can do. That is basically how Spin does something like outbound Postgres and outbound Redis, is that we've implemented those protocols in the host, and then we give you an API on interface for using it. But I wouldn't recommend going down that route, but I hope conceptually it makes sense in terms of how these things work. Oh, hi, OpenMeepo. Great to see you on the stream here in chat. And then might be early, but can you touch on integration, regression tests, as well as security tests? I'm not sure what you mean by integration, but when you say tests, I want to call out a work that Ryan Levick has been doing around Spin Test, which is a project that enables you to, it's a plugin for Spin. So basically, you install it into Spin, and then you can run Spin Test, and then you can run tests written in WebAssembly against the Spin application. And so this is actually a fairly new thing that Ryan has been working on, but basically this enables you to test Spin applications, and using some of those features that I mentioned early on with the component model and virtualization to virtualize a lot of the stuff, and you can even do some of that yourself. So take a look at Spin Test, and I think that's the direction I want to point you in terms of figuring out the type of test you can write and how you can test your Spin applications. Peter asked, do we get a Rust version? Peter, what? A Rust version of what? I don't know if you might have, this comment may have come a little bit late, but I did start by showing a WASI HTTP example in Rust. Basically, this is the example that I showed, Peter. So hello, WASI HTTP is just a Rust example, an example of writing a Rust WASI HTTP component incoming handler. I guess let's just call it an incoming handler. There's all these things like it's a proxy world, but it's an incoming handler, but it's also RAR. Anyways, this is your thing that handles HTTP stuff. Okay, and then there was an follow-up from, I guess, is it Mohammed Jaffa? I think I might have met before in either Discord or something. I'm not sure, but there was a follow-up question around testing multiple components running all together under Spin. Yes, I actually believe you can do that with Spin test. Well, yeah, that's actually a good one. Take a look at, so Spin test is supposed to, as far as I understand, run test against the individual Spin component. But maybe we should take a look here. Okay, so here's an app. This is a fun one actually, because I know Ryan loves to work with these components. So he wrote an app in Python and he wrote the tests in JavaScript, because I think we just want to show that because this is all component model and everything, languages really don't matter, which is quite nice. Let's see. So yeah, this is a single component application, but you can see it is calling both Redis and outbound APIs, using key value stores, using SQLite. It has a bunch of stuff. And if we take a look at the test written in Rust, yeah, we're basically doing requests. I couldn't see why you couldn't do this with multiple components, because we basically load the Spin application and then you can just start hitting. You can see we're sending a request, and if you had other components and other paths, I'm pretty sure you could do this as well. But take a look at the Spin test project, and if there are features not there that you think are good, join the party, contribute, open issues if you're not able to contribute or don't have the time to contribute, to share some of your great ideas. Yes, polyglot testing. Yes, interesting. It in itself is an interesting concept, I believe, if you want to figure out in isolation exactly what you're testing. Microsoft Edge browser, yes. Why not? I actually like it. I find it's good. It's Chromium underneath, right? But anyways, it's good. So okay, so that was a bunch of building WASI HTTP components and showing that we can actually do that with Spin. Now, I think I wanted to. So it's interesting, because why would we, I think the core thing I hope that you guys take away from this is that eventually we do envision that these HTTP components are, the same way that we think about libraries we have in package managers, or even containers. Like, there are functionality that are available out and that are shared. Either we share them, in our own little team, or we share them with the world. And you can basically just run these. You don't have to, as long as they conform to those interfaces, you can carry them around all these different hosts that have implementations. And really, like we can do with containers, but we have a way with WIT and the component model really to express what the platform is and what the host provides at a much, much higher level, that I believe is much more compelling for developer experiences, productivity, portability, all those types of things that we know WebAssembly is really, really good at. So that's sort of, for me, where the vision of this is going. And so let's try and go full circle with this, and maybe do something that might seem a little bit silly, because if you've used Spin, what I'm about to do right now doesn't make sense, and that's okay, because it has other purposes than necessarily making sense in terms of, would you go and do this? No, you wouldn't. But I hope that it gives you sort of an idea of really how all these things work underneath, and think about how you can use these tools to build stuff. So what I'm actually going to do now is I'm going to show you how we've done what it actually we've done with the SDKs that we build around Spin, because the SDKs are really a way for us to, if you go back and look at all this, the long list of things we need, all the way from the WIT definition to binding generators to build tools and runtimes and all these things, we really with Spin, tried to create a developer experience around all of this, right? So we bundle all these together in that developer experience. So if you sort of went the Spin route, you would do Spin new, you would get a template. That template uses the SDK. The SDK understand that there's a width definition we are targeting, and the SDK sort of do those templates. Well, the templates understand that there's build tooling that we need. So basically, we just write our code as we would do using any type of library in a I was just about to say normal environment, but in a world that's not necessarily WebAssembly. So the experience becomes what developers are used to today, and not a WebAssembly specific experience in that sense. And that is sort of what you can see we've done with Spin is putting these things together. But let's maybe rip these things a little bit apart, and let's not go the Spin new route, but actually just from ground up build a WASI HTTP component, but then using the Spin SDK, because that can show you how even those SDK could in itself make sense to have a more ergonomic or a more direct way of writing against the WID interfaces. And I believe that if you would start to define WID interfaces and use them more broadly, especially if you want developers to use your WID interfaces more broadly, then creating SDKs might be a really, really good way, because there are things that might not be easy to define in WID and then translate into through those bindings, where SDKs would make a lot of sense. Okay, so let's go ahead and try and do this. So basically, the first thing we're going to do is we need to have, well, I actually don't need that because I have it. I'm going to use Rust for this, but we need our Wasm 32 WASI target. And then we can go ahead and we can create a new library with cargo. So let's do this, and let's call this WASI live. And now I have a WASI live package. Okay, so let's go in here, and then I'm going to add two libraries to this, or I guess technically they're called cargo crates. I'm going to add the Spin SDK, and I am going to add anyhow. And I'm just going to add anyhow because we use that as part of the small code sample that I have here. And then if we go and take a look at what's going on in here, that's not what I want to do. I should have my light mode on as default by now because I've already changed it like 3 times. But anyways, let's go and take a look at the source. So basically, this is what comes with the default library. I don't know if this is called a template in Rust. Actually, there's stuff around Rust that I may not know. But anyways, we'll figure it out. Let's get rid of all that code, and then I'm just going to copy in some code that I have over here on the side, because you don't want to see me try and do this. So let's get that in here. So what we are doing here is, let's just write it. We are importing we're using these libraries, like we're using the Spin SDK up here, and importing some HTTP request response. We have this inter response method and an HTTP component. And really, the thing to sort of compare this with is going back to what we looked at over here in the, oh man, we've been in this case, right? So this is writing against the raw bindings, and this is using SDK. I mean, it's a small example, but it's far less code. It might be more intuitive to just use an SDK and implement an async function that handles a request and returns a response or result. Returns a response, sorry. So but SDKs are really a lot of opinions in the end, and hopefully productivity for those who use them. And this is one of the things we do in Rust specifically. We have this macro that actually turns this into an HTTP, WASI HTTP incoming handler. So we create that function, and basically we just return hello Fermyon in this case. And if you look at a cargo toml, you can see we have our anyhow and our Spin SDK. And one thing we need as well is to let Rust understand that this is going to be a particular type of compiled library that we need for it to actually have cargo compile into WebAssembly. Again, this is a detail. If you use the Spin tool, templates will make sure that all of this is set up. And that's actually it. That is all that we need if we want to use the Spin SDK to create a WASI HTTP component. So let's get out of this editor, and we should now be able to do cargo. Well, no, let's not do this. Let's do cargo component build and target WASI. What is going on here? Let me see. Bad history. There you go. Wasm 32 WASI. And we are now creating a WASI HTTP component again, but we did that using the Spin SDK and not using binding generators. And we don't have the WIT files because all of that is wrapped in the Spin SDK. And we should then be able to do spin up, and we will point at the is it Wasm? I always forget these things. There you go. And then I probably have a few of these running already. So let's just do something like this. And we can go and curl localhost 3003. And there you go. Hello, Fermyon. So again, we build a WASI HTTP component. We use the Spin SDK. Actually, we can do Wasm time serve as well. And I just want to show that we don't need pooling allocators and everything. Oh, wow. Okay, it's just Wasm time serve. And then let's take a look at the target. It's the other way around. First it's Wasm and then it's debug. Oh, man. Oh, that's interesting. Component instance was in CLI environment, but a matching implementation not found in Linker. So there might be a thing in here. This is interesting. Let me try one thing. I'm not sure this is going to fix it. What is going on here? Unknown. I'm not sure why the WASI 32 WASI is not able to run. But it's really hard spelling unknown. There you go. Okay, so let's dive into why this is happening. But there you go. Hello, Fermyon. Works. Okay, so we did a WASI HTTP component. So the thing is, when we actually the build targeting cargo, I assume when we do Wasm 32 WASI is that we have particular things that are being imported as part of that component that Wasm time serve does not provide, but that Spin provides. So this is probably an interesting point to consider, that the conformance of the world that the runtime implements where you want to run these and your component is like that's the fragility of this thing, right? That's where these things have to very specifically line up in order to actually work. And that's actually a super bridge over to something I just very quickly want to call out, that in Spin, there are two particular things that we're working on right now that I wanted to draw your attention to. When you think about how all these things sort of fit together, which is that number one is that there's nothing in what I just did where by using the Spin SDK that let me specify the world that I'm targeting, right? And so in that case, how do I know whether this component is a true WASI HTTP implementation or not? What was the other thing? That was the one thing. Yes. How do I know that? And we actually have, so in Spin, we have this concept of SIPs, so Spin Improvement Proposals. And that's actually not where they are. They should be over here. Yes. So we're actually working on a feature in Spin where we want to make it available through the Spin build process to help guide you around these target worlds and whether you're compliant or whether you conform to the specifications of those. So basically, the idea is that, so we're not going to read the proposal, but off of my mind, the way that I think this is going to work is that we would be able to, within spin.toml or through builds, somehow define the world that we want to target with our component. So as we develop along, we have spin watch going on, and we rebuild stuff like that. That feature will help guide us and tell us, whoa, we started to implement interfaces that are not available in those worlds, and so on and so forth, or whether there are interfaces that you have to implement for this component to work in that world. So that's one of these new experiences for developers around spin that helps sort of guide this whole world to WID, component guest to host relationship and how they actually work. This is what's cool about doing live stuff, is like you something doesn't work and you get off track, and then it gives you new thing to talk about or another thing to explore, which I think is super awesome. Okay, let's go back and I just want to follow up on chat before I want to show you the last thing here. So comment on spin running on a mobile. Using the right ones and run anywhere. Yes, how far are we? What the bindings look like? I don't think anyone is. I'm not aware of anyone having tried running spin on a mobile. But this is exactly what. This is why Google with Dart and Flutter spending a lot of time. I talked to some of the Google people a while back, and this is exactly what they want to do, right? They want to have Dart being able to support WebAssembly so that this exact thing can actually happen. I mean, spin is server side only, but if you take a framework like Dart, I think I think part of what they want to do is enable you to write these applications once and run them anywhere, like what we're doing with the the framework that every app uses, and it's basically just a browser without a browser. It's called something with E. I'm totally blanking on that one now. Help me out in chat if you know what I'm talking about. So yeah. So Bunny, not sure YouTube log my last post. It had a URL, but no, I don't see the URL here. I don't know if it ended up in YouTube as well. I'm seeing this from another chat, which is the place where we run this. Wait. If you can do spin on a Raspberry Pi, then for sure you can build an Android cluster. I guess so. So yeah, I know Rado has a Raspberry Pi cluster, at least. We brought that to a few conferences by now. I haven't seen an Android cluster yet, but I guess it'd be interesting to wire up a few old phones and see if you can make that work. Okay, cool. Seems like we're getting a little bit off track here, but thanks for all the questions and chiming in with comments here in the chat. Okay, so the last thing that actually makes my demo here of using the Spin SDK and not the Spin CLI to build something that we can run with Spin is to now actually go ahead and create a Spin application, and then running the HTTP component the WASI HTTP component that we just created, again without using the fullness of the Spin experience, but I hope you get the point, even though that it's weird. But let's do this. Okay, so spin new. Sorry. The first thing we need to do is now the other thing that so Bunny tried URLing again, and it's not happening. Actually, let me just see. I cannot. Yeah, I'm not seeing it here as well. Sorry. Okay. But the thing that I just wanted to show you in the end is that we have, I mentioned this early on, but there's definitely still some work in progress around distributing with definitions. And the other side of that, so as we move down the road, as we move from width to actually building stuff, we also want to distribute the components, right? And so part of what we have been doing, we as others have been doing is like we want to use the OCI specification for this, right? Because container registries or OCI registries are everywhere, and everyone has one. So why not reuse that, because it works really, really well. So the same way that you can, push spin applications using spin registry push as a command, you can also push individual components to OCI registries. Again, a lot of this is like super, super early on. The project that is used is, I'm blanking right now. It's called WASI package, something like that. Let me just find it. Wasm package tool. This one, another bytecode alliance project. There you go. So Wasm package tool. So this is the tool that will help us take individual WebAssembly components, package them up, and distribute them using OCI. Again, this is super, super early, but it's something you can play around with today, and it sort of gives you this idea of what workflows eventually can be. Okay, Bonnie finally got the URL dropped in Discord. This is why you want to have more than one chat system, I guess. The way that we use this is that we can use a client called ORAS, O-R-A-S, to actually push stuff. And then what Spin has done, Spin has implemented that WASI package tools that I just showed before. So basically, this is a library, this is a crate. Spin implements that, so Spin understands how to use this to pull components, WebAssembly components, from OCI registries. What I'm going to do is I'm going to use the ORAS tool, and as you can see, I've actually done this before. Let's call this WASI live, because we're live. This is WASI we're doing. And so one thing to notice here is that there is actually a certain convention you have to follow for this to work, at least with Spin. So I'm using TTL.sh. I think we call it out all the time. It's an ephemeral container registry, or OCI registry, that a company whose name starts with R, and I'm totally blanking on what the name of the company is. They host it. It's awesome. Use it. The only thing you actually have to both add a, I think we call these namespaces and then package name. So you have to use this convention to both have a namespace and a package name, because that's the convention that we use for pulling these components through the Wasm package tools. And then the other thing is that your versioning, or the tag that you use in OCI language, has to be a valid semantic version. So as long as you follow those things, you're good. And then we will push that thing. And what it is that we want to push is we want to push target, and let's actually use the one that also worked with Wasm time. And then we should be able to go to debug. And there you go. That's the WebAssembly we want to push. And then we have to tell it that it is an application Wasm that it has to be packaged as. Let's see if this works. Okay. There you go. We have our 9 megabyte WebAssembly. Well, okay, it is debug build, and we do have all the backtraces in there. We can actually strip this down to probably less than a megabyte, I would assume. Cool. Okay, so we actually now have our WASI HTTP component, which is not a Spin application, because Spin applications always require spin.toml. So if you use Spin registry push, it will fail miserably because there is no spin.toml, and that's what it expects. We should probably fix that, but we'll get to it. But meanwhile, you can use ORAS, and we now have this component sitting in TTL.sh. So this is where things become spitty, because now we want to build a Spin application. So let's do a new Spin application, and let's use the famous empty template, which means that, let's call this WASI live. I'm not going to call it WASI live because that already exists. So let's call this WASI live spin. There you go. And we should now have a WASI live spin directory. And if we go in here, we have a spin.toml. Okay, so now we can actually within this spin.toml, we can add our component. And I am just going to copy this again because I'm not going to write this in here. But you can see we're now adding an HTTP trigger, listening on all routes. We're using the WASI HTTP component to serve this, and the WASI HTTP component is now pulling this component from TDL SH. The package is called, I now forgot what I called the package. So let me just go and merge my history, and we should be able to see that. What did I call it? Oh, this is exactly what I called it. Okay, that's easy. Okay, so, and you can see this is actually where that whole naming convention came in, right? We have the registry, we need a package, needs a namespace and a package name. I think these are called namespaces, although it's something I'm probably making up, I don't know. But and then version has to be a semantic version. And now we have, I guess, the most silly spin application you can imagine, which is a spin application with just a spin.toml file, loading a component from a registry that uses the spin SDK, but we actually didn't create it as a spin application. But let's do spin up. We're now loading the Wasm components. It's taking a few seconds. Listen. There you go. Listen, and there you go. And we should be able to curl 3005. And woo! We've gone full circle of building probably the most silly spin application ever. But anyways, I hope this, I mean, even though that I still think the example is silly, I hope this gives you sort of this idea of how all these things sort of work together, and hopefully also a little bit of like, you know, turning spin inside out and showing how, on one hand, you can say how I actually believe in it. I'm pretty proud of being part of a company where we've been able to create this nice developer experience that sort of gleans over all these implementation details that are within all these tools that are being pulled together, right? Of having standardized ways of defining what is expected from my guest and the host where it runs, giving an awesome developer experience by providing SDKs that sort of wrap these bindings and gives a more meaningful way of interacting with those standard interface definitions. Wrapping the build tools and the runtime, and implementing with how we can actually distribute our components and use them in various places. So that is what I wanted to show today here in our live code session. We are coming up on the hour, and I think we got the URL thing sorted. And yeah, so now there is, okay, so if you don't know what to do over the weekend, there is a link on how you create a compute cluster out of old mobile devices. And then if you can, you know what, let's make a deal. If anyone builds a cluster of old mobile devices and gets spin up and running on that cluster, you get a full hour of live stream with us, and you can show us your work. I promise that. Just reach out to Discord and we can figure that out. That will be a fun thing to do. Cool. I think that's it for now. I'll just keep monitoring the chat a little bit, because my streaming is a little bit ahead of what comes in on the chat. But thanks everyone for watching. Video will be shared on YouTube, and hope to see you next week again for another live streaming session. Thanks.